Live connected. Live connected. நானே பண்ணிடுறேன். நீங்க பேசுறது தான் சரி. நல்லா இருக்கா? சார் ஜாயின் பண்ணிட்டாங்களா? சுகுமார் சார். வந்துட்டாரா? குட் மார்னிங் சார். Good morning, Sukumar sir. Good morning, Tamil ma'am. Ma'am, it is audible?
Yes, sir. Good morning, sir.
Yes, ma'am. Good morning.
Sir, is my voice is audible, sir? Sorry, sir.
Sir. இல்ல சார் மைக் ஆன் ஆகல. Good morning sir.
Good morning to all. Good morning to all.
Okay sir.
Okay.
Correct 11 start. Ma'am, almost registered participants உள்ள வந்துட்டாங்களா? The 2 minutes. Good morning, Tamilarasi ma'am. Shall we start the program?
Good morning, sir. Can start பண்ணலாங்க sir.
Yes, ma'am. Very good morning to one and all. I welcome Professor Dr. Sukumar sir to give an welcome address for this event.
Yeah, thank you, sir. It's my pleasure to be. Good morning, everyone. I am thrilled to welcome you all to today's third National Research Workshop on Digital Image Processing. It is an honor to have such an enthusiastic and diverse group of participants from various locations coming together in this virtual space. Despite the distance, we are united by our shared goal to learn, collaborate, and grow. Today's session promises to be an exciting and insightful experience with Dr. V.Thamilarasi ma'am working as assistant professor at Sri Sarada College for Women affiliated to Periyar University in Salem. About where she has attended many FDPs and she have got short-term courses and MOOC activities and she published 7 journals and written 2 chapters in books and she had a total presented 4 papers and she is also a Computer Science Association Secretary and Tamil Kanini Association Secretary in the college. Welcome you, ma'am. She brings a wealth of knowledge that will help us all deepen our understanding of digital image processing. Whether you are here to enhance your skills, gain new perspectives, or engage with like minded peers, the workshop is designed to be interactive and impactful. I encourage you to make the most of this opportunity by participating actively. Ask questions, share your ideas, and engage in discussion. Let's embrace the power of digital learning and create a collaborative environment, even from afar. Before we dive into today's agenda, I want to thank each of you for taking the time to be part of this session. Your presence reflects a commitment to professional growth and continuous learning. I am confident that by the end of this workshop, we will all walk away with valuable insight that can be applied in our respective fields. Once again, welcome to the workshop. Let's make today productive, engaging, and most importantly, enjoyable. Thank you, and let's get started.
Thank you, Sukumar sir.
Thank you, sir.
Thank you.
Thank you, sir. And I extend my special address to Tamilarasi ma'am. Good morning, everyone. It is a great enthusiasm that I extend a warm welcome to our esteemed speaker for the third National Online Workshop on Digital Image Processing, Dr. V.Thamilarasi ma'am, Assistant Professor, Sri Sarada College for Women affiliated to Periyar University. She is a distinguished expert in the field with extensive research and a practical experience in digital image processing. Her work has significantly advanced our understanding of the subject, and her innovative contributions continue to inspire both students and professionals. Today, we have the unique opportunity to learn from her insights and expertise. Dr. Tamilarasi ma'am availing to convey complex concepts with clarity and passion make her an exceptional educator, and we are privileged to have her with us. She shares her knowledge and guides us through this engaging workshop. We are excited to learn from you, ma'am, today. Thank you, ma'am. I hand over the session to Tamilarasi ma'am. Please continue.
Thank you, sir.
Thank you.
I am very happy to be a part of this workshop series, sir. I am very thankful to Sadish Kumar sir and Sumar sir and the organizer, Charanya madam. Thank you so much for everyone for giving me this nice opportunity. Okay, shall I start the presentation, sir?
Yes, ma'am. You can proceed, ma'am.
Is it visible, sir?
Yes, ma'am. It's visible, ma'am.
Okay, sir. So good morning to one and all present here. I am Dr.V.Thamilarasi from Sri Sarada College for Women. I am Assistant Professor of Computer Science. Okay, today let's discuss some of the important and basic concepts of digital image processing. Before go into the topic, first we have to know about what is image, why we need image processing. We know what is image. Image is a collection of pixels. So all the pixels present in rows and column wise. So these rows and columns simply form any photograph or any image. But why we need a digital image processing? Simply it's a image. It's already taken by any cameraman or mobile phone or any capturing tools. But why we need image processing? Because while we capturing an image, definitely there is a different illumination, a different environment, and there is a chance of more noise, there is a chance of a degrade of the image. So that is the reason we go for digital image processing. And normally is it need for a normal photograph? This means surely it need, because while we taking that's why many events and functions need a particular photograph. After that, those images going to be blow by using some DTP techniques. So in terms of in healthcare analysis, digital image processing is a dominant one, because all the images were captured among different environment and different patients. So maybe it's a brain tumor image, maybe it's a lung cancer image, maybe it's a liver cancer, maybe it's a ovarian image, maybe it's a heart disease image. So the images are available at different type in healthcare industry. So definitely they need some radiological support. Then only the medical practitioner can easily identify whether the particular patient has a disease or not. So that is the reason we need a image processing. So image processing is a process of transforming an image into a digital form. So clearly understand, the image is transforming into a digital form and performing certain operations to get some useful information from it. Because while taking some x-rays, while taking some scan, we didn't, in manual view, we didn't capture any information from the image. But while we are doing a digital image processing with the help of radiologists, definitely we can observe there is any particle, any object present in the x-ray or scan reports. This is the reason we go for image processing. So whether it is a simple process or not means definitely it's a very complex one, because it depends on image, the process is going to be varying. If it is a healthcare image, if it is a lung cancer image, otherwise if it is a lung image, it's a very difficult one, because lung is a small portion in our body, but definitely there is around some other organs. So in while taking x-ray, definitely it shows what it belongs. So particularly extracting the particular lung portion from the X-ray image is very difficult. So definitely it need a different pre-processing technique. The same is go for a brain image. The same is go for a ovarian image. So depends on type of image and depends on type of disease analysis. The pre-processing technique may be vary. Okay, normally the image pre-processing technique starts from image acquisition. So maybe it's a photographic image, maybe it's a scanned image, maybe it's a X-ray image. Then image restoration. So based on the type of analysis, the image is going to be converted in a different restoration. Maybe it's a 256 or 256, or maybe it's a 1026 and 1026. So that is the row and column based pixels. So then definitely it need a image enhancement. So that's the reason I am told definitely every image need some enhancement. The image is going to be process or diagnosis for particular disease identification or particular defect detection and particular fault detection. So definitely if the image is clear and perfectly only we can get a high accuracy. That is the reason we go for an image enhancement. The image enhancement, we have a lot of techniques available. For example, we can use filtering, we can use noise removal techniques, we can use histogram equalization, then we can use image enhancement techniques. That is the contrast enhancement techniques. So depends on image only, we are going to decide among these enhancement technique which is we are going to be used. Then after the enhancement, directly it go to the segmentation. First, we have to decide whether the particular image or particular disease diagnosis or particular object fault diagnosis need an image segmentation or classification. If it is a image segmentation, means it directly go to the image segmentation. Then in image segmentation, surely there is a lot of image segmentation techniques available for image. Then after the image segmentation, we go for feature extraction. If we need a classification, if we don't need a classification, means we simply stop in a segmentation. So here every step is depends only on the what type of image we are going to handle for what type of disease analysis and why it is needed. Depends on the user requirement and application requirement. Only these techniques going to be decided by the user. So what is pixel? So pixel is a picture element. So every image is formed the help of pixel only. If the pixel is a clear only, we can get a perfect image. If the image is a perfect image, then only we can process it through any pre-processing techniques or any segmentation technique or any classification techniques. We can simply apply these image segmentation techniques or image classification techniques or any pre-processing techniques. Okay. To how the data are handled in image processing. So before that, so we have an image. If it is a X-ray, means it can be available in 256 and 256. That is row and column wise. If it is a brain images, it can be available in even 128 to 128. So depends on the image and the disease analysis and the type of photograph, the pixel is varied. So if I need to practice these images, I need to put these images in deep learning, means definitely I need a higher pixel classification. That is higher pixel clarification. For example, if I am going to segment a dog, means if I am going to segment a apple, means which is easily get answer, means the apple is easily get answer because it has only it's a round and it has one stem. But while I am going to in a segment in a dog or any animals, but definitely it has to consider many features. So everything, if I am going to refer a particular feature, means I need a clear pixel, then only I can easily capture those pictures. So before that, any image going to be handled, the image is going to be transformed, different transformations. maybe the image restoration going to be handled. Maybe the image resize is going to be handled. Maybe the image scaling, that is rotation, 90 degree, 80 degree, 180 degree, 360 degree, like that. Then shifting, horizontal shifting, sorry, left and right shifting, and flipping, horizontal and vertical flipping. So these are the some transformations before we fed the particular image into the process. So these are the some common pre-processing techniques. Here, thresholding is a very, very basic and common pre-processing techniques. It also acts as the segmentation techniques. Then median filter, and it's one of the pre-processing techniques which is used to remove the noise. Then the grayscale is one of the basic formation. Then image resizing is a basic formation. The fuzzy logic and green pixel matching, these are only applied when we are using in a clustering. So depends on type of image, the pre-processing technique definitely going to be vary. So for example, in this picture, we can clearly see while we applied filters, here I applied mean filter. So the particular picture, maybe you can easily see it is distorted one. But while I'm using a mean filter, there only it also not produced a good result. But while compared to the previous image, it's a dull image. So it's not a perfect one. In an image noise, we can easily see the last one image is a perfect image noise removal. That is the last one box in the particular image is a particular noise removed image. The other noise removal is not successful one. Same way in threshold, it's the best. It is the one of the best image pre-processing and segmentation techniques. You can clearly see it because it simply avoid other objects in the picture. It simply captures the man with the camera. So it is the best in image. Then in image edge detection, you can simply it doesn't provide a good edge detection, because for a human face, it has a lot of features: the eyes, nose, lips, ear, hair. So depends on the image only we have to apply, but we cannot directly apply any technique to any image. We have to first experiment which type of technique is suitable for which image. For example, in this image, surely it's not a good segmentation. So it's not clearly detect every edges. For the first image, it detect the head around the edges, but it not clearly detect the other features. The another one image, it's totally remove all the edges. So definitely for this picture, edge reduction is not suitable. Like that, in the first image, the mean filter is not suitable for this image. So through experiment only, we can select whether the particular technique is suitable for particular image. That is the reason many people think image processing is a very complicated one. But while you are working in image processing, you can feel it's an interesting one, because we can experiment any technique for image. We can experiment that result going to be a very interesting one. So the next one is the image segmentation. So image segmentation is a computer vision techniques. So it simply partition a digital image into discrete group of pixels. For example, if I give a brain image, means I have to analyze a cancer, brain tumor in the brain image, means it simply segment the particular tumor. But how it is possible, I have to check, because there is a lot of segmentation techniques available. For example, first one is the binary thresholding, then morphological thresholding, then clustering, then granule based segmentation. So there is a lot and lots of segmentation technique available, but depends on picture only. We can select the particular segmentation technique. So it's the most commonly used image segmentation technique. That is the region based, then edge reduction and thresholding. Because these three techniques simply produce output if you give a proper image. If you give a proper image means definitely it should bring a perfect result. So what is thresholding? Here force thresholding is one of the famous one, because everyone know force thresholding produce output for any image. It has no it has no conflict, or it has no differentiation for image to image. It produce better result for any image. That's why we are always preferred thresholding method, particularly what's the thresholding. It may be suitable for agriculture field. If I am going to segment a particular leaf, I am going to segment a particular grass, I am going to segment a particular flower, then the what's the thresholding is a very useful one. Then region growing and region splitting. Region growing and region splitting. The region growing is maybe here before we used it for a clustering. In clustering is a region growing. It worked based on the principle of region growing. So we used region growing in a clustering segmentation. So after showing some discussions, definitely I will give you a demonstration. Then you can easily understand why I am differentiate like this. So then the region splitting. Mostly we didn't use region splitting because while we already know pixel is a 0 or 1. 0 is a black, 1 is a white. So every pixel definitely be a 0 or 1. While it is present in a row and column wise means if I am going to use a region split means what is happened there. Definitely there is a loss of some image portions. That is a loss of prominent features in the image. So that's why image processing researchers not preferred region splitting, but it can be used while we used in some different type of data set, like okay, maximum we didn't use it, but in satellite images. In satellite images, we can use region splitting because that images contain more and more number of objects in a particular image. In that case, we can surely use region splitting technique. But maximum region splitting technique can't be used for medical image analysis or any fault detection or any object detection segmentations. Then edge detection method. It is also one of the interesting image processing technique because we know the image has definitely surely be a borders. And the border means, for example, in one, if you just think about one photograph, in a photograph, we are in the middle of photo, around the photo, we have some background. But while we take processing for that photo, what is happening? We already know definitely each photo has some noise, each photo has some prominent features. So while I am going to process a segmentation, while I am going to process a classification means definitely I need a pre-processing. But while I'm using but the particular photograph for segmentation means what's happening before pre-processing, definitely there is a noise. So due to that noise, we have a loss particular important features and the photograph. So that is the reason we use the edge detection method. What is the role of edge detection method in a particular photograph? So normally edge detection technique, it simply adds 0 to the corners. We already know 0 is a black, so not 1 is a white. So definitely we need a segmentation always a white portion, that is 1. We don't need a black portion, that is 0. So it simply put the corners of image 0. So then what's happening? While we are doing any processing, any edge detection means it simply remove the 0 portion only. So we can still get the proper photograph. This is the reason we are going to use the edge detection method. So in edge detection method, we have four commonly used operators, that is the Sobel operators, Prewitt operator, and Robert operator, and Canny operator. In that Sobel, Prewitt, and Robert, Canny is the best operator because Canny produce, otherwise Canny not destroy the edges like Sobel, Prewitt, or Robert, because these operators, for example, the Sobel operator uses convolution filter to approximate the gradient of the image intensity at each pixel. So it's not compulsory to use 3x3 filters. We can use any number of filters. Okay. So whatever the Sobel operator, I will show you the demo, then you can understand what is the difference between Sobel, Prewitt, and Robert operators, because these operators maximize, even if I am add 0 to the corner of the image, surely it destroy the image portion, surely it remove the image portion. This is the reason we are prefer Canny edge reduction. So here double thresholding is possible. So this is the reason why Canny not remove important feature from the photograph. Then we can easily, it can easily track the weak edges. So it simply remove the weak edges. It capture and prevent the loss of prominent features. So this is the reason we go for a Canny edge reduction. So still now we have some basic understanding about the image. The first one is what is image. The image is a combination of pixels, that is 0, 1, 1, which is present in a row and column wise. Okay, simply a row and column present of pixel matrix created a one image. Okay, image processing, where we can apply image processing. Image processing can be applied in any object detection. Maybe you know about YOLO 5, YOLO 165, 128, like that. The algorithm has to be extension till now. So bounding box techniques, we can use image processing in a bounding box techniques. We can use image processing in a fault detection, then defect detection, if the fruit is a proper fruit or there is a defected fruit. And we can use prominently, we use image processing in a healthcare industry. So in healthcare industry, we can apply it for a lung, we can apply it for a brain, then we can apply it for a ovarian, liver, any type of image which is available as a X-ray or available as a scan report. So with the help of radiologist, we can easily get these images. So for a particular disease diagnosis, definitely we need those photographs. So this can be presented in a form of data set. So the particular data set fed into the any model, any machine learning model and deep learning model, definitely it needs some pre-processing technique. So depends on the type of analysis, the pre-processing technique is going to be differ. Maybe it's a filtering, maybe it's a noise. I'm simply said filtering. Really, there is a lot of filtering available. Mean filtering, median filtering, adaptive histogram filtering, like that. Every noise, then a Gaussian noise, then salt and pepper noise, then content enhancement techniques, then white pixel techniques, grayscale image techniques. So like it's also one of the pre-processing techniques, and image resizing and image transformation, scaling, rotation, flipping. So all these are basic pre-processing techniques, but these techniques not suit for all images, depends on the type of image we are going to analyze. We select any one or any two of these pre-processing techniques, depends on user application or requirement. Okay, first the data set is fed into the input, then after that it is going to be pre-processing step. After the pre-processing, it's going to be segmentation or classification. If it is a segmentation, definitely it's going to be segment some portion from the one photograph. Maybe it's a cancer, maybe it's the object, maybe it's a defect, maybe it's a fault. Okay, whatever, it's going to be capture one from the particular image. So this segmentation also varied from image to image, because in clustering is not suitable for lung images. At the same time, thresholding is not suitable for brain images. So particular images only works based on particular techniques only. The brain tumor images maximum used clustering technique and fuzzy logic only. But at the same time, lung images maximum use thresholding techniques, granule based segmentation technique, then RGP based segmentation technique. So like that. So depends on the image, the segmentation technique is also going to be differ. So after the segmentation, we defined what type of the segmentation we are going to done for a particular image. So after that, we need a classification, means definitely we need a feature extraction. So what is feature extraction? Feature extraction is, so already I told every photograph has some dominant feature, some weak features. What is dominant feature? If or one human photograph, if it is a human photograph, means the eye, nose, lips, the whole face area, the hair, ears, all is some dominant features. The background is a weak features. So classification needs a dominant features only, then only it can learn whether the given image is a human or not human. So in a machine learning or deep learning, definitely we need a feature extraction. In machine learning, we need an external feature extraction, but in deep learning, the feature extraction is done by internal layers. So we didn't externally fix any feature extraction technique externally. So this is the difference between machine learning and deep learning. So while we use a machine learning or deep learning in a classification, surely there should be applied some feature extraction techniques. Okay, there is a lot of feature extraction techniques available. For example, grayscale co-occurrence matrix. So it is the most commonly and frequently used one because it's suitable for any type of image. Some feature extraction techniques not suitable for all type of images, like few not used for APIL images, few techniques not used for object detection images. So maximum healthcare industry, otherwise any disease diagnosis, they used a grayscale co-occurrence matrix. So here it considered a few features, that is the based on entropy, based on the homogeneity, based on the energy, based on the contrast. So these are the 4 dominant features which can be considered in a particular photo. So it produces some values while processing. So based on that value, the classification is going to be done in a machine learning. But if it is in a deep learning, what is happening? CNN has automatically feature extraction. We didn't need any external. So simply it takes the input, the max pooling layer, then activation layer, then it is going to be a convolution layer. This process is repeated until 3 layers. Finally, we have a fully connected layer. In fully connected, we have a sort path function and activation function. So it surely identified whether the given image is a 0 or 1, that is yes or no, whether it is a disease or not diseased, whether it is a fault one or not fault one, like that. So in deep learning, the image classification is very simple and neat. It can produce a high accuracy, but only in terms of if the images is high resolution and high count. If you have the image data set with the large number of count, means definitely you can apply deep learning. But is it possible segmentation in deep learning? Means surely it's possible, but UNet and UNet versions only produce good result for medical images. The other versions still in a developed stage and still in a experimental stage. That is the reason most of the people not go for segmentation, because first identifying segmentation itself is a difficult one for a particular image. After that, the classification it's another complex one problem, because we have a lot of default deep learning architectures. We cannot simply put or experiment particular images to your all architectures. Because for example, I can say lung images produce good segmentation and classification result by using unit. At the same time, while I am using a brain tumor image, that is brain tumor disease diagnosis, if I am using a brain image in unit segmentation and unit classification, means surely it's low. If lung image produce 97 something accuracy, means brain image produce only 80 something, because brain images produce good result while using clustering techniques only. So this is the reason the complexities arise between the handling of images. So depends on type of requirement, we are going for a classification. The classification simply classify whether the given object is a apple or not apple, whether the given object is a human or not human, whether the given object is a animal or not animal, like that. So yes, it's only simply predict yes or no. So it's a classification. So it's a on simple whole setup. So first data acquisition, then data pre-processing, then segmentation, then feature extraction, then classification. It is the simple setup. Basically, we consider for image pre-processing. But how we can say my experiment is good, even I am get 97 accuracy, is it possible to claim my experiment is produce 97 accuracy for segmentation, so my algorithm is best? Is it good or bad? Definitely it's a bad one, because this is the reason there is some evaluation metrics available, whether the produced result is a good one, whether the produced result is a correctly produced, whether the produced result correctly identified these are deceased people, those are not deceased people. So that is the reason we are go for evaluation metrics. So evaluation metrics simply identified whether the given result or produced result is corrected from the given input data set. That is the it simply measured how many correctly classified, how many correctly segmented. So like that. Is evaluation metric is same for both segmentation and classification? Means surely not, because segmentation is a pixel grouping, but classification is a class division. So both need a different evaluation metrics. In that case, in segmentation, most popularly we used dice coefficient, Jaccard coefficient, structure similarity index, feature similarity index. But structure similarity index and feature similarity index is a very complicated one. If you have a surely high accuracy ground truth image, then you can go for structure similarity and feature similarity. Otherwise, most commonly used evaluation metric is dice coefficient and Jaccard coefficient. It simply overlaps ground truth image with the segmented image and produce the accuracy, how much the image is corresponding to the segmented image. So here what is ground truth? Ground truth is nothing but a mask, and that is the basic image. In other words, we can say, while we getting a segmentation, we get some portions only white. Okay, so the same original copy of masked image is called here ground truth. Okay, definitely there is a difference. The ground truth image simply shows the whole portion of exact, for example, exact portion of the lung, exact portion of the brain. But original image is a X-ray copy or scan copy. Okay, so this is the difference between original image and ground truth image. So ground truth image is simply a mask of original image. So it compares
Ma'am, sorry for the interruption. Your voice is not
the
audible.
from the brain. So
Tamilarasi, ma'am. Tamilarasi, ma'am.
long process. Hello, sir.
Ma'am, your voice is not audible by last 30 seconds. It's breaking.
Sir, but sir,
Mic is
actually
going
the
on.
mic is, but the mic is on, sir.
Yes, ma'am, mic is on, but last 30 seconds is not audible. Okay, ma'am, you can continue.
Okay, sir.
Thank you.
Now it's audible, sir.
Yes, ma'am. Yes, ma'am. It's now audible.
Okay, sir. So for segmentation, the evaluation metrics we can use Jacob coefficient and Dice coefficient, structure similarity index, and feature similarity index. For classification, we use F1 score, accuracy, precision, recall. This is the difference between classification and segmentation evaluation metrics. So depends on type of operation only. The evaluation metrics also going to be used for particular operation. So image segmentation simply had a 4 evaluation metrics, but in classification we have several evaluation metrics. AUC, ROC depends on if we need a ROC AUC curve means we are going for those evaluation metrics. But normally we used only accuracy, precision, recall, and FN score because it produced what the image, what the data set has, and what the result is produced. So it compare both produced result and actually what we have. So depends on it. It evaluate whether it correctly classified, whether it correctly identified the deceased person as a deceased person, whether it correctly identified all deceased persons are really a deceased person, and it also identified these are not deceased person. So these are the 3 common metrics which is used for classification. So it's if these values are nearby 1 means surely it's a good classification. If these values are below 6 or below 7 means surely it's a not better classification. So these are the basic setup for image processing from data acquisition to classification. So now we go to demo section. Okay. So is it visible? Hello?
Yes, ma'am, it's visible.
Is it visible?
Yes, ma'am. Collab is
Thank you, ma'am. Thank you, ma'am. Okay. Okay, normally we use image processing in MATLAB only, but it takes more time to load. That's why I am use Colab for running a program, just showing a demonstration. So there is a 2 type of image uploading. Here I use only a single image. That's why I just choose a file from my computer. If I have a large data set, I can simply get it from my drive. That is this Colab drive. So here I use only 1 image for demonstration. That's why I'm get it from my system. Here you can see it's a one of simple pre-processing. So here you can see the image. The first one is the real original RGB image. While it converting a RGB, it's going to be a grayscale image. Here is the histogram equalized image. It is the contrast enhanced image. So this image needs this type of operation, and this image produce good result for this type of operation. So I am used here this only. The same way I can resize the image. Here you can see flipping, rotating, then horizontal and vertical flipping. Like you can see the differentiations. So these are the some pre-processing techniques we can use in image. It's another one example. You can simply see it. It is a horn. You can view the differentiation. It's a original image. It's a content enhancement image. Okay, if I am doing this type of pre-processing, means how I can measure whether the output image is quality one, whether the output image didn't contain any noise, how it can be measured. That's why we simply used SNR, PSNR techniques to identify whether the produced image is a perfect image or whether the produced image is a not perfect image. So for simply demo, I didn't use the technique here, but in another demo I have used. So these are the some available filters: the Gaussian filter, median filter, Sobel filter, and Laplacian filter. Here you can easily see which filter is from good. The Gaussian filter is only good the human view, but while applying an PSNR, SNR value only, we can define which filter is good choice for a particular process. Here you can see the thresholding. It's the original image. It's a threshold image. Adaptive mean thresholding, adaptive Gaussian thresholding. Here adapting mean thresholding is a good choice because in adapting Gaussian filtering, the pixels are scattering. In global thresholding also some pixel is removed. So adaptive mean thresholding only capture all pixels. So it's a good. So here you can see the edge reduction. It's a Sobel edge reduction. It's a canny edge reduction. You can see the difference. In canny edge reduction, it captures every minute features in the original image. But in Sobel edge reduction, it simply reflect like a thresholding. So here it didn't capture all dominant features, but in a canny edge reduction, it captures all dominant features. This is the reason canny is the most preferable one for image pre-processing. It's simply image resize. Okay, it's a segmentation. It's a clustering based segmentation. I simply used one of the lung image. Now you can see it's the original image. It's a segmented image, but it's only a segmented image. Here no disease diagnosed. It simply segment particular lung portion from the image. Hereafter the disease diagnosis taken place hereafter only, whether the particular segmented portion contain cancer or not. So it's another different extreme. So here I only segmented the image based on clustering. So for the segmented image and original image, I calculate SNR and PSNR value. You can see SNR value is 1.51, PSNR value is 28.93. So here PSNR value is considerable for this output, but SNR value is very low. So definitely the output image contain more noise. While seeing the image blindly, we can say, oh, it's good class segmentation. But while considering evaluation metric, it's not a good one. That's why the SNR value is it's very, very, very low, and so the result is very, very poor. But the PSNR value is 28.93. So the PSNR considerable range is 30 to 40 dp. So it's more or less it's acceptable, but it's also a worst one. So this segmentation is not good. That is, it does not produce a good segmentation while using clustering. So this is the reason clustering is not suitable for lung images. Okay, for same images, I have used dice coefficient and Jacob coefficient. Here you can see the dice coefficient is 0.521. Jacob index is 0.335. So both values are very low surely the produced output segmentation is worst case. So this is the reason the both coefficient produced low value for the image. Okay, for classification, so actually it's a diabetic data set. I simply classified. So and also merged my own data set, my real-time collection data set. So I merged both data set simply using a exploratory data analysis. So if you need means you can use this one type of plots, otherwise not used. Okay, here you can easily see the variations. So I used the features blood pressure, age, BMI, smoking habit, alcoholic habit, insulin, glucose. Actually, this research focused on really what is the reason for diabetics. Diabetic arise based on what type of features. For example, in real-time data set, they consider only glucose, insulin, BMI, age, and blood pressure. So that I feel most alcoholic persons and most smoking persons easily get affected by a diabetic. So I have collected these features from many persons from hospitals and colleges and universities. So based on that, I have matched those two features. Actually, I have collected nearly 20 features, but I only matched two features because the other features does not produce proper correlation. So that is the reason I used ED analysis. First, I have to find whether my given collected feature is correlated to my point. That is my objective. It's not correlated to my objective. So that's why I neglected those features. But these two features is minimally correlated. So that's why I take alcoholic habit and smoking habit as a two features to match for the old feature data set. Actually, here you can see it's a ROC curve and F1 score. Here you can see the value 0.652. F1 score is a harmonic mean between precision and recall. So that is the imbalance between, it's used to show the imbalance between the class. So it's only a 0.652 for trying, 0.557 for test. So however, it's a wrong classification. The another one is a 0.764 and 0.7007. It's also a wrong classification. Just to see the classifiers, first I have used logistic regression as a classifier, and next one I used k nearest neighbor classification. The next one is a decision tree. Here more or less okay result because the train is 0.83 and test is 0.81. It's a considerable value. In decision tree, it produced a considerable value. In random forest, the test value is reduced, but the ROC score value is 0.933. Here the ROC score value is 0.92. So here we consider random forest is a good classifier for this diabetic data set. So it simply predict, simply classify how many people has a diabetic and how many people has no diabetic. So this is the one of the, it's a data set classification. For example only I have simply done this. Wait, I have some binary classification. Okay, it is one of the image classification. It's available in this documentation place, that is Python library, and PyTorch library also it's available. So it's they simply use the dense-net classification. The horse is going to be classified whether the given is a horse or not. This is the objective. So they simply classified The data set contain five types of five classes, then dog, then white wolf, Keeshond, Arctic fox, Pomeranian, Samoyed. So these are the five classes which is available in a particular data set. It is available in HitCup. So while classifying, you can see how many number of images present in a particular class. Yeah, 1.76, 2.36, 2.55, 4.34, and 86.7. Here, so this is the dominant feature data set. This is the dominant photograph data set. The remaining at the next is go to white wolf. The next is go to Keeshard. The next is go to Arctic fox. Then the last one is a Pomeranian. So it's only a least count that you can easily see. It's a multi-class classification. So here it's simply classifying with the range. So we can compare both is same because this bar chart and that these values equally same. So this is the multi-class classification. In image classification normally happen like this, but here this program is different. That's why they use simply a density classification. So like this, if it is a CNN classification, we can use other evaluation metrics, accuracy, precision, recall, FN score, ROC, AUC, everything. So depends on what we are going to achieved, what is our goal, whether I am going to predict this is a horse or not horse, other I am going to predict whether these are animals, these are humans, whether those are deceased people or not deceased people. So like that. So depends on our objective or goal only. We can decide what type of technique is going to be used. It's another method of classification, but here I simply learn every feature. In a total data set, I simply learn every features. Actually, it takes more time. This program is only halfway running, so still it needs a further processing. So because of time, I skip this. So there is a lot of method for any segmentation or classification. We can use any type of output or any type of visible method for a particular diagnosis or any type of classification for particular diagnosis. But all these features or all these classifications, all these segmentations only based on type of photograph and type of analysis. So what type of photograph going to be used for what type of analysis? So depends on our motto only these techniques going to be considered. So maybe now you have a simple idea of what is image processing, why we need a image processing, what are the simple steps involved in image processing. So image is a collection of pixels which is arranged in a row and column matrix. Those are 0 and 1. 0 is a black and 1 is a white. While for segmentation, it considered only white. So for every process, it needs 5 basic steps: data acquisition, data pre-processing, and segmentation, then feature extraction, then classification. If it is a deep learning means picture extraction not need, it simply go for segmentation and classification. But deep learning techniques only suitable for classifications probably because most of the healthcare or fault detection images not produced good result in deep learning techniques because those are default architectures. We simply change the layers, we simply add the layers, and we simply restrict the filters. But other than that, we cannot change anything. We simply improve the algorithm. But while in a machine learning, we can create an algorithm. We can develop a new algorithms. For example, I have created 7 algorithms for my research. Okay, this is my research area. I have developed. Okay, here in my research, I have found what is the threshold value of a lung image, because the threshold is very dominant and basic feature for any segmentation. If I find a correct threshold only, my image is going to be segmented correctly. If I can't find my threshold, if I can't fix my threshold correctly, means then the image definitely surely not produce a good segmentation one. So I have found my lung image, that is JSRT. I have used JSRT data set, which is available. It's an open and golden metric data set. So I have found those 56 images, every image threshold values, for which threshold value the particular image is segmented. Based on that threshold value, I have created 5 algorithms. So those 5 algorithms used automatically segmented based on threshold value. Among all 256 threshold value, I put one threshold value as a border one. So I fixed that particular threshold value in my all algorithm and segmented the image. So for first I get only a low accuracy only. After that, only while going, depends on my algorithm, the accuracy is differs. If it is automatic thresholding, it is the first automatic thresholding. So it produced only 80%, like that only. I have also experimented the previous algorithm more, so NIBlack and Savola. Okay, it is the one of the best. That is the green channel based automatic threshold. I have produced 3 algorithm for one thresholding, automatic thresholding algorithm. So I have just separated all 3 channels, red channel, green channel and blue channel. For each channel, I have produced an algorithm, but my green channel algorithm only produced high accuracy. So I give green channel based automatic threshold is a successful one for lung application. Then granule. Here before no one used granule for lung segmentation. Only one person used then for satellite images. For I am used granule segmentation for lung images. So simply putting entropy values, based on the entropy value, I fixed granule size. Based on that granule size, the image is going to be segmented. But while considering accuracy, the granule based segmentation is a very tough one. So it's a little bit lower than other algorithms. But it's a first attempt. So it's a, in my point of view, it's good for lung images. So the other one is the ensemble based segmentation. Here I combined my previous 3 segmentation and produced the ensemble based segmentation. I combined my 3 own algorithms and produced a new algorithms. It also produced a good result for lung images. You can see the difference. Algorithm 1, algorithm 2, algorithm 3. While ensembling, it produced 86.20. But we didn't manipulate any results. Whatever result we get, we simply put it. So it's also lower while compared to the automatic threshold, because automatic threshold produce higher result than this result. I am using UNet for the deep learning. So in the UNet segmentation, it's produced a perfect segmentation result. While I'm using a machine learning algorithm, I feel those algorithm produce even more algorithm produce good segmentation result for log image. But not all the algorithms produced high accuracy. So that's why I feel UNIT is the best segmentation algorithm for lung images. At the same time, I also used UNIT for classification. It's my own structure, which is I improved from the old structure. So in this classification also, I attained high accuracy. So these are my research papers. So surely now you have some understanding about image and image segmentation and image classification techniques. It's a very interesting area. If you have any doubt means, surely you can ask me. I will give you my number. This is my number and WhatsApp number. Whatever doubt, kindly ask me. Nearly I have worked 70 or 80 different images. So I have some idea about those images. Maybe there is I can answer a lot of questions if you have. Sir?
Ma'am, good afternoon. Ma'am, good afternoon.
Good afternoon, ma'am.
Ma'am, image filtering technique, there are so many methods are there. You can say
Yes,
Gaussian filter, Sobel filter, operator and Laplacian Gaussian filter. Three
Yes,
methods are best. How to say the three methods are best?
Three methods are best. Is it, ma'am?
How to say?
Okay, ma'am. Ma'am, while we using a filtering, that's why I told we can use SNR and PSNR values. Based on SNR, PSNR value, we can say this filtering is good choice for this image. I can put any type of filtering, all produced output. But எல்லாமே ரிசல்ட் ப்ரொடியூஸ் ஆகும். நம்மளுக்கு பார்த்தா தெரியாது, பார்த்தா எல்லாமே நல்லா இருக்கிற மாதிரியே தெரியும். பட் ஆனால் நம்ம அதை எப்படி கண்டுபிடிப்போம் அப்படின்னு பார்த்தீங்கன்னா, இந்த எஸ்என்ஆர் பிஎஸ்என்ஆர் வேல்யூ வச்சு தான் நம்ம கண்டுபிடிப்போம். இப்போ எனக்கே பார்த்தீங்கன்னா அந்த எஸ்ஐஎன்ஆர் வேல்யூ நான் காமிச்சப்ப கம்மியாக இருந்தது, பிஎஸ்என்ஆர் வேல்யூ கொஞ்சம் தான் அதிகமாக வந்தது. ஆனால் எப்படி பார்த்தாலும் உங்களுக்கு அது ராங் ரிசல்ட் தான். அப்போ என்னோட அவுட்புட் வந்து நல்லா ப்ரொடியூஸ் ஆகலை. நான் வந்து கிளஸ்டரிங் வச்சு லங்க் கிளஸ்டரிங் வச்சு செக்மெண்ட் பண்ணுறேன். பட் ஏன்னா என்னோட ரிசல்ட் பார்க்கும்பொழுது எனக்கு அப்படியே நல்லா நீங்க கண்ணில் பார்த்தீங்கன்னா எல்லாமே கரெக்டா செக்மெண்ட் ஆன மாதிரி நம்மளுக்கு ஒரு வியூ தெரியும். பட் ஆனா அங்க நிறைய போர்ஷன்ஸ் மிஸ் ஆயிருக்கு. அது மிஸ் ஆனதுனாலதான் எனக்கு என்னன்னு வருது, அங்க லோ வேல்யூஸ் வருது. இப்ப எஸ்என்ஆர் பிஎஸ்என்ஆர் வேல்யூ வந்து 20 டெசிபிள் அண்ட் 50 டெசிபிள் இருக்கு அப்படின்னு வச்சீங்கன்னா அது வந்து கரெக்ட். ஆனா எனக்கு எவ்வளவு வந்திருந்தது அப்படின்னா 1.25 அப்படின்னு இந்த டெமோல நான் சொல்றேன். 1.58 சம்திங் வந்திருந்தது. அது இன்னொன்னு வந்து பிஎஸ்என்ஆர் வந்து 28 சம்திங் வந்திருந்தது. ஸோ நீங்க எப்படி பாத்தீங்கன்னாலும் டிபெண்ட்ஸ் ஆன் பிஎஸ்என்ஆர் எஸ்என்ஆர் வேல்யூ வச்சு மட்டும்தான் நீங்க சொல்ல முடியும் அந்த பர்டிகுலர் ஃபில்டர் இஸ் குட் ஃபார் பர்டிகுலர் இமேஜ் அப்படிங்கிறத நீங்க கண்டுபிடிக்க முடியும். சேம் இதே தான் நீங்க எட்ஜுக்கும் யூஸ் பண்ணுவீங்க. எஸ்என்ஆர் பிஎஸ்என்ஆர்ங்கிறது தான் நம்ம எட்ஜுக்கும் யூஸ் பண்ணுவோம், மார்பாலஜிக்கல் ஆப்ரேஷனுக்கும் நம்ம யூஸ் பண்ணுவோம், தென் இந்த ஃபில்டரிங்க்கும் யூஸ் பண்ணுவோம்.
SNR and PSNR value na enna
ma'am? Signal to noise ratio, peak signal to noise ratio. So இது என்ன பண்ணும் அப்படின்னா அந்த இமேஜ்ல எவ்வளவு நாய்ஸ் இருக்கு அப்படிங்கறத ஐடென்டிஃபை பண்ணி சொல்லும். அது ரெண்டு ரெஃபர் பண்ற விதம் வேற. என்னன்னா பீக் சிக்னல் டு நாய்ஸ் ரேஷியோ என்ன பண்ணும் அப்படின்னா, இப்ப என்னோட ஹியூமன் பெர்ஸ்பெக்ஷன் என்னவோ அதே மாதிரி பார்த்து அதுல என்ன நாய்ஸ் இருக்கு இல்ல அப்படிங்கறது சொல்லும். பட் சிக்னல் டு நாய்ஸ் ரேஷியோ என்ன பண்ணுனா ஹியூமனோட வியூவை வந்து அவாய்ட் பண்ணிரும். அது என்ன பாக்குதோ அதை தான் அது நாய்ஸா எடுத்துக்கும். அதனாலதான் அது வந்து ரொம்ப லோவா இருக்கு. பட் பிஎஸ்என்ஆர் வேல்யூ பாத்தீங்கன்னா 28 வந்திருக்கா, அப்ப அது எனக்கு பாக்குறப்ப எனக்கு அது நல்லா இருக்கிற மாதிரி தெரியுது. சோ பிஎஸ்என்ஆர் வேல்யூ அதே மாதிரி தான் கன்சிடர் பண்ணும். ஸோ இது ரெண்டுல எது பெஸ்ட் அப்படின்னு பாத்தீங்கன்னா அப்படி பெஸ்ட் அப்படின்ட்டு எல்லாம் இல்ல. ஆக்சுவலா இது ரெண்டுல எது ஹையா வருதோ அதை நம்ம எடுத்துக்குவோம்.
Specifically, we can use it any other parameters. You can calculate for SNR and PSNR.
மேம் ஆக்சுவலி நம்ம இதுதான் மேம் மேக்சிமமா யூஸ் பண்ணுவோம். ஆனா இமேஜ் பொறுத்த வரைக்கும் உங்களுக்கு எல்லாமே லிமிட்டெட் தான். இந்த டெக்னிக்ஸ் யூஸ் பண்ணாதான் இதுக்கு நல்லா வரும் அப்படின்னு நம்ம இதை சொல்ல முடியும். ஏன்னா எனக்கு தெரிஞ்சு நம்ம மேக்சிமமா யூஸ் பண்றது PSNR SNR வேல்யூஸ் தான். ஏன்னா இதுதான் ஒரு அளவுக்காவது ரிசல்ட் ப்ரொடியூஸ் பண்ணும். இன்னும் 2 மெட்ரிக்ஸ் இருக்கு. பட் அந்த 2 மெட்ரிக்ஸ் வந்து மேக்சிமமா யூஸே பண்றது கிடையாது. அது நல்லா ரிசல்ட் ப்ரொடியூஸ் பண்றதும் கிடையாது. அதே போலதான் உங்களுக்கு எவாலுவேஷன் மெட்ரிக் எப்படி நீங்க செக்மெண்டேஷனுக்கு ஒரு 4 யூஸ் பண்றீங்க, ஒரு கிளாசிபிகேஷனுக்கு ஒரு 4-5 யூஸ் பண்றீங்க அப்படின்னா அது எல்லாமே ஸ்டாண்டர்டு தான். ஏன் அது ஸ்டாண்டர்ட் அப்படின்னா அது எல்லாம் தான் அதுக்கு நல்ல ரிசல்ட் ப்ரொடியூஸ் பண்ணுது. பட் இதுவே நீங்க ஸ்ட்ரக்சர் சிமிலாரிட்டி இண்டெக்ஸும் ஃபீச்சர் சிமிலாரிட்டி இண்டெக்ஸும் எடுத்துக்கிட்டீங்கன்னா அது ரெண்டும் ப்ரொடியூஸ் பண்ணாது. ஏன்னா அது இன்னும் நிறைய ஃபீச்சர்ஸ் கன்சிடர் பண்ணுது. ஒரு இமேஜையும் ஒரு செக்மெண்டட் இமேஜையும் ஒரு கிரவுண்ட் ட்ரூத் இமேஜையும் நான் தரேன் அப்படின்னா அது ரொம்ப நிறைய கன்சிடர் பண்ணுது. ஈவன் நான் ஹியூமன் என்னோட பர்ஸ்பெக்ஷன் என்னவோ அதை அப்படியே அதை கன்சிடர் பண்ணும். பட் டை சிமிலாரிட்டியும் ரெக்கார்டு சிமிலாரிட்டியும் என்னோட வியூவை வந்து கன்சிடர் பண்ணாது. பட் ஃபீச்சர் சிமிலாரிட்டி இண்டெக்ஸும் ஸ்ட்ரக்சர் சிமிலாரிட்டி இண்டெக்ஸும் என்னோட வியூவை கன்சிடர் பண்ணணும், ரெண்டும் கால்குலேட் பண்ணும். ஏன்னா எவ்ரி ஃபீச்சரை அதை கம்பேர் பண்ணும். பட் டைஸும் ஜக்கார்டு சிமிலாரிட்டி வந்து மேக்ஸிமம் ஃபீச்சர்ஸை மட்டும் கம்பேர் பண்ணிக்கும். டாமினன்ட் ஃபீச்சர்ஸ் என்னவோ அதை மட்டும் கம்பேர் பண்ணிக்கும். ஸோ அதனாலதான் அதை நம்மளுக்கு எது நல்லா ரிசல்ட் ப்ரொடியூஸ் ஆகுதோ அதை நம்ம எடுத்துக்குவோம். பட் சம்டைம்ஸ் ஜக்கார்ட் சிமிலாரிட்டியோ இல்லை SNR வேல்யூ PSNR வேல்யூ ரொம்ப அதிகமா இருக்கும். பட் ஆனா இமேஜ் பாத்தீங்கன்னா நம்ம வியூல பார்க்கும் பொழுது ரொம்ப டல்லா இருக்கிற. பட் அந்த டைம்ல நம்ம என்ன பண்ணுவோம் அப்படின்னா செக்மெண்டேஷனோ இல்ல கிளாசிபிகேஷனோ பண்ணும்பொழுது இங்க நல்லா வந்திருந்தாலும் அங்க நல்லா வராமையும் போகும். அதுக்கு காரணம் நாய்ஸ் தான். ஏன்னா இமேஜ் தான் பர்ஃபெக்ட் இமேஜ் அப்படின்னு நம்மளால சொல்லவே முடியாது. இதெல்லாமே ஜஸ்ட் ஒரு மெட்ரிக்ஸ், அவ்வளவு.
ஓகே, தேங்க்யூ மேம்.
Thank you, Shanti ma'am. Questions from other participants?
Yes, sir.
Good afternoon, ma'am. I'm Saranya. My question is, which technique is best for image processing, ma'am? Hello, ma'am.
Hello. Hello. Hello.
Saranya ma'am,
Hello?
you can ask your question one more time.
Ma'am, which technique is best for image processing, ma'am?
Which pre-processing
Yes.
or processing?
Image
Ma'am,
processing.
இல்ல இமேஜ் ப்ராசஸிங் அப்படின்னா நீங்க அதாவது அங்க இமேஜ் ப்ராசஸிங்கிறது இது எல்லாம் சேர்ந்துதான் இமேஜ் ப்ராசஸிங். நீங்க டேட்டா அக்விசிஷன்ல இருந்து கிளாசிபிகேஷன் வரைக்கும் போற எல்லாமே இமேஜ் ப்ராசஸிங் டெக்னிக் தான். பட் இதுல பெஸ்ட் டெக்னிக் அப்படின்னு பாத்தீங்கன்னா டிபெண்ட்ஸ் ஆன் இமேஜ் பொறுத்து தான் நான் அது வேரி ஆகும். இப்போ ப்ரீ ப்ராசஸிங் அப்படின்னா என்னோட லங் இமேஜுக்கு எது நல்லா வந்ததுன்னா மீடியன் ஃபில்டர் தான் நல்லா வந்துச்சு. பட் நான் அங்கே நியர்லி ஒரு 15 ஃபில்டர்ஸ் நான் யூஸ் பண்ணேன். பட் அது நல்லா ப்ரொடியூஸ் ஆகலை. ஸோ அந்த மாதிரி டிபெண்ட்ஸ் ஆன் இமேஜ் இந்த ஃபில்டரிங் டெக்னிக்ஸும் டிஃபர் ஆகும். இப்போ இதுவே நீங்கள் பிரைன் டியூமர் எடுத்து பிரைன் இமேஜ் ஒன்று எடுத்துக்கிட்டீங்க அப்படின்னா அது வந்து அடாப்டிவ் மீன் ஃபில்டர் தான் நல்லா ஒர்க் ஆகும். மற்ற ஃபில்டர்ஸ் அதில் நல்லா ஒர்க் ஆகாது. ஸோ டிபெண்ட்ஸ் ஆன் நீங்கள் என்ன டைப் ஆஃப் இமேஜ் என்ன டைப் ஆஃப் அனாலிசிஸ் பண்ணுறீங்களோ அதை பொறுத்து இது எல்லாமே வேரி ஆகும்.
தேங்க்யூ மேம்.
Thank you, Saranya ma'am. Questions from other participants? Questions from other participants? Ma'am, Thamilarasi ma'am.
Yes, sir.
Ma'am, actually, thanks for giving a brief explanation about that image processing in all steps with metrics and all values. And there is many data the researchers community will get you from the Colab live demonstration.
Okay, thank you so much, sir. Thank you so much for giving me this nice opportunity, and thank you for participants and organizers and everyone present here, sir.
Yes, ma'am. Shall we go for a vote of thanks, ma'am?
Yes, sir. Sure, sir.
Yes, ma'am. I welcome Ms. Gayatri, ma'am, from SKRGC Research Group of Companies to give a vote of thanks.
Good afternoon, everyone. I am Gayatri. On behalf of SK Research Group of Companies, as we wrap up the third National Online Workshop on Digital Image Processing, I would like to take a moment to express our sincere gratitude to our esteemed speaker, Dr.V.Thamilarasi ma'am. Dr. Thamilarasi ma'am Your expertise and insights into digital image processing have greatly enriched our understanding of the subject. Your ability to present complex concepts clearly and engagingly made this workshop not only informative but also inspiring. We appreciate the time you took to share your knowledge and the practical application you discussed. I would also like to thank all the participants for your active engagement and thoughtful questions, which contributed to the success of this workshop. Your enthusiasm for learning has been truly commendable. Thank you once again, Dr. Thamilarasi ma'am, and to everyone who joined us today. We look forward to implementing what we have learned and hope to see you at future workshops. Thank you.
Thank you, ma'am.
Thank you, sir. Thank you,
Thank
ma'am.
you, sir.
Thank you, Thamilarasi ma'am. Thank you, Shanti ma'am.
Thank you, sir. Thank you, sir.
I thank all the participants and delegates